This is Limits Day 3 notes. Okay, we're going to talk about continuity today at a certain point. So it says a function f is continuous at x equals c if all the following are satisfied. So the first thing is f of c is defined. It says the limit as x equals c, your function has to exist. The limit as x equals c, f of x has to equal f of c, meaning this has to equal a point. Okay, it says why are the following functions not continuous at x equals c? So I've given you this first graph. So as you approach c from the left side, we approach c at this. We approach c from the right side, we approach this hole. So we're approaching a hole basically. So f of c is not defined because we're approaching a hole. Okay, so not defined, and I would say this is because of number 1. Okay, on B, as we approach C from the left side, we're coming to this point. As we approach C from the right side, we're approaching this point. We're approaching two different points, so that C is not defined or does not exist. So I would say the limit as x approaches c does not exist, and this would be like number 2. Okay, and of course this is going to be like number 3 because as we approach c from the left side, we approach this hole, and as we approach c from the right side, we also approach this hole. So we're not going to a certain or a specific point. So as the limit as x approaches c, it does not approach a point, and that would be like number 3. On a one-sided limit, the limit of f of x as x approaches c is L, and this is if and only if the limit as x approaches c from the left side, remember that c with a little negative means left side, the limit, your function is equal to L, and the limit as x approaches c from the right side, your function is equal to L. So basically your function has to equal L from the left and the right. Okay, from your graph B from above, as you approach your function from the left side and from the right side, has different values. Hence, as x approaches c, your function does not exist. So basically it has to equal the same thing or it will not exist. So let's look at this. Find the limit approaching 1 from the negative side. So let's approach 1 right here, this line right here, from the negative side. So as your function approaches 1 from the negative side, then you're going to get this point right here, which is -2. As your function approaches x right here from the positive side, then you're going to get this number, which is 1. And since we have two different numbers, then the limit as x approaches 1, your limit is not going to exist since we have two different numbers. Okay, it says graph each function, find the limit approaching c from the left side and from the right side. Determine if each function is continuous. If it's not continuous, state where it is not continuous and describe why using the definition of continuity. Okay, so I'm first going to graph this at c equals 0. So plugging in 0, absolute value of 0 over 0. And your graph, we've graphed this one before, is going to be plugging in the absolute value of 0. It's going to look like this and like this. Okay, so the limit as x approaches 0 from the negative side of your function is going to be equal to a -1. Okay, on B, it says find the limit as x approaches 0 from the positive side. Your function would be a +1. Coming from the negative side is a negative, positive side is a positive. Okay, C says determine if it's continuous. Since we get two different answers, positive and a negative, then it's not going to be continuous. So I'm going to say this is not continuous at x equals 0 because f of 0 is not defined and the limit as x approaches 0 of your function does not exist. I'm not sure if these are fixed on yours, but I'm going to fix them on mine. This should be x is greater than or equal to, and this should be x is less than. All right, so now we can fix this. How about we graph? So x squared needs to be greater than or equal to, and that's going to be a parabola. And then this is going to be 2x minus 1, so this is minus 1 with a slope of 2 and over 1 and over 1, and this is going to be open, and that is just a straight line down. Okay, so now we can answer our questions. So A, the same thing, find the limit coming from the left side and find the limit coming from the right side is B. So the limit as x approaches 2 from the left side, your function would be 3. On B, your limit as x approaches 2 from the positive side, your function is going to, oh, it looks like 4. Okay, since these are two different answers, this is not continuous. Again, at x equals 2, because f of 2 is not defined, and the limit as x approaches 2 of your function does not exist. Okay, for number 3, see as c equals 0. So let's graph this one. I've got two linear functions here. 1. So this is going to be less than 0. And then when I go above 0, I'm going to have a slope of 3. Okay. It's all connected, so let's see if this is continuous. So as the limit as x approaches 0 from the negative side, your function is approaching, it looks like -1. And on B, the limit as x approaches 0 from the positive side, your function is also approaching -1. So it looks like this one is going to be a continuous function, including x equals 0, because we're talking about 0 here, because f of 0 is defined, and we can say our limit as x approaches 0 of your function is equal to f of 0. Okay, on this next section, you do need your calculator, and I'm going to show you how to use your calculator on this. It says use the table on your calculator for numbers 4 through 6 to find your limit from the left side, the right side, and to see if it exists. So take a minute and plug number 4 into your calculator. Okay, with it plugged into Y1, I'm going to go to my table set. Since I want to see if it exists at 2, I'm going to make my table start at 2. Then I'm going to go to my change in table, and I'm going to change this to, oh, I don't know, 0.001, or you can plug as many zeros as you want to. The more zeros you plug in, the more accurate it's going to be. I'm going to go to my table. At 2, it does say it's 0. From the bottom part, that's going to be the right side. So it looks like it's approaching 0 because this E, the scientific notation, is 0. If you go above 2, you can see it's also approaching 0. Okay, then we can go over here from the left side. Your limit is approaching 0. From the right side, it's also approaching 0. Then we noticed it said at 2, when we looked on the table at 2, does the limit exist? And we're going to say yes, because at 2, it was at 0. D says, is this function continuous? And we're going to say yes. Okay, on number 5, I'm actually not going to use my calculator on this one. I'm just going to, because this is a piecewise function, this linear function is going to be, if you had -1, this function is going to go to the left, and this parabola is going to go to the right, whatever this function looks like. So all I need to do is plug this -1 in. So this is 3 times -1 plus 7, and that should be equal to 4. And then to plug it into the right side, I'm going to say -1 and square that. Add 2, and that's equal to 3. And since this function approaches 2 different numbers, is the function exist? And this would be no. And is it continuous? And that would be no. And it's no because the limit as x approaches -1 does not exist. Okay, again, I want you to go to your calculator and plug in number 6. Okay, looking at my function, I have it plugged in, making sure you have absolute values. So I'm going to go back to my table set. I'm looking as it approaches -5. And again, I went down here and I left it at 0.0001 to make it the most accurate that I could. Go to your table. At -5, I have an error, so that means that the limit doesn't exist or that it's not continuous. From the right side, it looks like it approaches -1.6. From the left side, it's approaching 1.6. So if I go back to my page, from the left side, it's approaching 1.6. From the right side, it's approaching -1.6. Does it exist? That would be no. Is it continuous? No. And we're going to say it's not continuous because the limit as x approaches -5 your function does not exist because there was an error. On number 7, again, I'm not using my calculator because I know this one right here, x does not equal 1. This could represent my left side, and this at 3, this could be my right side. But this one's kind of weird. It looks like I can factor the top, so I'm going to do so really quick. This is x plus 1 and x minus 1 over x minus 1. These cancel. So really, this top piecewise is just an x plus 1. And I have a hole at 1, 2. So if you kind of look at the graph of this, it's going to go through 1 with a slope of 1. So it looks like this. You have a hole at 1, 2. So there's your hole. But then this says that you have a point at 1, 3. So this is this piecewise function. So I can answer everything from this. So from the left, it looks like your function is approaching 2. From the right, my function is approaching 2. Does this limit exist? And I would say yes. It's approaching 2. Is this continuous? Absolutely not. And it's not continuous because as your limit, as it approaches 1, your function is not equal to the function at 1, meaning your function's not equal to the point because your point is equal to 3. Right, this last one should be pretty easy, but let's look at it. It says, what is the limit as x approaches 2 from the positive side? What is your function equal to? So let's look at 2. And let's approach it from the positive side. So let's go in from this positive side here. From the positive side, so the only function I see is this one right here. And it is approaching this number, which is -3. Okay, let's approach -2. And it doesn't say positive or negative, so we're going to approach it from both sides. So negative 2, if we approach it from this way, it's this point. If we approach negative 2 from this way, we've got this point. So it looks like we have two different answers, so I'm going to say this does not exist. Okay, I'm going to approach 2 from the negative way. So positive 2 from the negative way. 2 from the negative way gives me this number, and that looks like it's a positive 3. 5, nope, that's a 6 from the negative. So here's 6 from the negative position, 6 from the negative position, and it looks like your function's going all the way down here to a negative 4. Okay, this is 2. This is a negative 2 from the negative side. Negative 2 from the negative side. Looks like your function's getting closer to positive 2. That's what your function's getting closer to. Okay, this is a 6 from the positive side. 6 from the positive side. I do see this point, but my function's getting closer to this number, which is 4. This is a 4 from the positive side. So 4 from the positive side. Looks like I probably have an asymptote here. So 4 from the positive side goes to infinity. But anytime it goes to infinity, I'm going to say that it does not exist, because I don't know what that number is. Okay, now I'm saying 0 from the positive side. So here's 0 from the positive side. Looks like it's getting towards 0. Okay, and this last one says, for what values of the constant c is a function f continuous on negative infinity to infinity? In order for this to be a function, I need it to be defined. We need it to exist. And in order for it to exist, it needs to be continuous. Okay? Okay, in order for it to be continuous, then what we can do with these right here, we can take this piecewise function and figure out basically what my number is when x is 3. So I'm going to take c and I'm going to plug in a 3 plus 1, and I'm going to see what it equals when I plug in a 3 down here as well. So c times 3 squared minus 1. And I'm going to solve and see what c is possible to be. Okay, so this would be 3c plus 1, and this would be 9c minus 1. So this would be 2 equals 6c, or c is equal to 1/3. If c is 1/3, then the function will exist. The function will be defined. Therefore, it will be continuous. And it all depends on c being this point.